So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over the GCSE Maths Higher Practice Paper of 2023 Set 4 Paper 2, which is a calculator paper. And as always, I'll include a question breakdown in the description below so you can see which question refers to which mathematical topic. So let's get started on this practice paper of 2023 Higher Set 4 Paper 2, which is a calculator paper. So looking at question 1, we want to work out what 5 to the power 12 divided by 5 to the power 3 times by 5 to the power 2 is as a power of 5. So for this, what we need to do is we need to simplify this. Now, it doesn't matter what order you do things because dividing and multiplying are on the same line of BIDMAS. So if you want to work left to right, that's absolutely fine. Or you can do it in sections, it's entirely up to you. But hopefully you should get the same answer of 12 minus 3 plus 2, which gives us an answer of 7. So here it's going to be 5 to the power of 7. Then moving on to question 2, here we've got some column vectors. So here all we need to do is just do minus 4 plus minus 5 and then do minus 7 plus 3. Now minus 4 plus minus 5, well that becomes a minus. So minus 4 minus 5 is minus 9. And minus 7 plus 3 is minus 4. So the column vector for our answer here is going to be minus 9 and minus 4. Then moving on to question 3, it says work out the nth term of this linear sequence. So for this, what we need to do is work out the difference between the term to term, which is plus 4. So that means that 4n is going to be in the formula. And then what we need to do to get from the 4 to the first term, which is a 3, well, we need to take away 1. So that means then that the nth term is going to be 4n minus 1. Then moving on to question 4, it says f of x equals 8x minus 5. Work out the value of f of minus 2. So what we need to do here is basically substitute x equals minus 2 into this function. So here I've got 8 minus 2 minus 5. So 8 minus 2 is 6 minus 16 minus 5 is minus 21. Then moving on to question 5. So here we've got to work out the length of x, and this is a trig question. So I start by labeling the components I know. So this is theta, so that's going to be the opposite, and that's going to be the hypotenuse. So I'm going to be using sine. So I've got sine theta equals O over h. And then substitute the numbers in, I get sine 20 equals x over 12. So x equals 12 multiplied by sine 20, and if I type that into my calculator, I get an answer of 4.1, and that's to 1 decimal place. Then moving on to question 6, it says write 140 as a product of their primes numbers in index form, and it's worth 3 marks, which I'll be honest is quite surprising, only because we can do this on our calculator, but I'll show you how to do it if you do not have a Casio calculator. So here we want to do a factor tree, and in which how you break this up is entirely up to you. And basically what you want to do is stop when you get your prime numbers. So here the correct answer is going to be 2 to the power of 2 times 5 times 7. Now if you've got a Casio calculator, then there is a function that will do this automatically for you. So all you need to do is just type in the number that you want, press equals, and then press shift, and then just as a second function you should see the word fact. So if you press that, and ultimately it will give you the correct answer, which it has done. Moving on to question 7, it says £6,000 is invested at a 2.5% compound interest. Show that the value of the investment after 2 years is £6,303.75. So for this, what we need to do is write down our starting value. Then we want a 2.5% increase, so we add 100 to 2.5, which is 102.5%, and then want to convert that as a decimal, which is 1.025. And then we want to do that to the power of however many years, and if I type that into my calculator, I get the answer that they told me I would get, which is exactly the same as what they've shown. It then says in the 3rd year the interest rate falls to 2.4%, and in the 4th year the interest rate falls to 2.35%. Will the interest for year 4 be more or less than the interest for year 3? and we need to tick our box. So the first thing we need to do is work out what amounts we're going to get in the third year. So for the third year, well, the starting amount in that third year is going to be, after the second year I should say, is 6303.75, and so I'm then going to multiply that by 2.4% increase. So even though it says it falls, it's only because it's gone from a 2.5% to a 2.4%. So that's going to be 1.024, and if I type that into my calculator, I get an answer of 6,455 and 4 pence. So from this, what I can then work out is what the interest amount is going to be, and I do that by taking away this answer to what I had before. So if I take those two numbers away, I get an answer of £151 and 29 pence. So that's how much interest I accumulated in that third year. I then need to repeat the process for the fourth year, in which that's going to be the starting amount, which is now 645504. I multiply that by a percentage increase of 2.35%, so that's going to be 1.0235. And if I type that into my calculator, I get an answer of 6606.73. So then working out the interest that I've accumulated in that fourth year, well, I do that by taking away this number from this number, in which I get an interest amount of £151 and 69 pence. So the correct answer is going to be more, and the reason for that is because 151.69 is greater than 151.29. Moving on to question 8, it says work out the value of A and B in this identity. So here what we need to do is we need to expand and simplify this left hand side. So if I just write that down, and then if I expand the brackets, I get 2x plus 2b. Now that is the equivalent of 22x plus 6. So then if I look at the coefficients of x, so then I look at what's got an x, well, I've got 5a and I've got a 2 on the left hand side. So that's going to be 5a plus 2, and that equals the number in front of x on the right hand side, which is 22. So that means then 5a is going to equal 20, so a equals 4. Then if I look at the constant, so if I look at the coefficient of the constant, so here I've got everything that hasn't got an x, well, I've got 12 and I've got a 2b, and that needs to equal plus 6. So that means then that 2b equals minus 6, and so b equals minus 3. And there I've got my two values of a equals 4 and b equals minus 3. Then for question 9, it says the nth term of a sequence is n squared. Which term in the sequence is the first one with a value greater than 1000? Well, for this, if I square root 1000 on the calculator, I get an answer of around 31.6. So that means that the value of n needs to be between 31. So if I do 31 squared, well, that gives me an answer of 961, which is less than 1000. But if I do 32 squared, then I get 1024, which is greater. And as you can see, so the correct answer is going to be the 32nd term. Moving on to question 10, it says that the table shows the waiting time in T of people at a health centre, and the question is asking us to work out the estimated mean time waited per person. Now we don't know the units, but that has no significance. So working out the mean from group data is we need to first of all work out the midpoint between the groups. So to work out the midpoint, I just take away the upper bound by the lower bound. So that's going to be 5, 15 and 25. I then need to create an fx column, and the fx values are done by multiplying the numbers in the frequency column by the midpoint. Now for more than 30, that's 0 anyway, so that's going to be 0. So here we've got 42 times 5, which is 210, 30 times 15, which is 450, and 8 times 25, which is 200, and that is a 0. So then to work out the estimated mean, it's going to be the total fx over the total frequency. Now the total frequency, well, the frequency is 80, and the total of the fx values, if I add all those three numbers up, is 860. So it's going to be 860 divided by 80, which gives me an answer of 10.75. Now I don't need to worry about the units because there's no units in the time allocated, but I would say that it's probably going to be minutes rather than hours, although with current NHS standards you never know. Moving on to question 10b, it says on a different day the waiting times were recorded for a different group of 80 people. Without further calculation, decide whether the estimated mean for this group of people will be different from the estimated mean in part A, and we need to tick our box decided. Now the correct answer for this one is going to be that it is higher. Now the reason why it's going to be higher, if I just move across, I've got more space, is that because there are more people in the 10 to 20 and 20 to 30, and I should get rid of that line there, not that they'll probably penalise me for it, but there you go. So this will increase the mean time to wait. So something along those lines would be absolutely fine. And then moving on to question 11, it says the diagram shows a semicircle of diameter of 15 centimeters inside a rectangle, and you want to work out the shaded area. Well, for these types of questions, the shaded area is often the big shape, which is the area of the rectangle, minus the area of the smaller shape, which in this case is a semicircle. So for this, I first of all need to work out what this length here is. Well, if that semicircle fits nicely into the rectangle, then if this length here is 7.5, then that means that the height of that semicircle is also going to be 7.5. So then the area of the rectangle is going to be 7.5 multiplied by 15, which gives me an answer of 112.5. Then to work out the area of the semicircle, well, the formula for that is the area of a circle divided by 2. So we know that the radius is 7.5. So then the area is going to be pi times 7.5 squared divided by 2. If I type that into my calculator, I get 225 over 8 pi. So then all that's left for me to do is then take away the area of the rectangle by the area of the semicircle. So on the calculator, I could just write the shaded area is going to equal 112.5 minus 225 over 8 pi. And if you've written that as a decimal, then that should be absolutely fine. But your final answer should look something like this. And that's been rounded to 2 decimal places. Now, if you round it to 1 decimal place, that's absolutely fine. Just make sure you are writing whatever you have rounded your answer to. Moving on to question 12, it says that y is inversely proportional to x for positive values. When x is 3.8, y equals 4. Work out the value of x when y equals 2.5. So the first thing we need to do is write this using mathematical notation. So y is proportional to the inverse of x. So if I replace the proportional symbol with equals k, I then use these values to then work out what k is. So 4 equals k over 3.8, so k equals 3.8 times 4, so k equals 15.2. Or you can write it as a fraction, that's entirely up to you. So then from this, my formula is y equals 15.2 over x. So then substituting this, what we then want to work out is x. So I've got 2.5 equals 15.2 over x. So x equals 15.2 over 2.5. And if I type that into my calculator, I get an answer of 6.08. Now, if you're not sure about how I've got from this to this, well, if I take the x over to the other side, I end up with 2.5x equals 15.2, and then I take my 2.5 over, so then x equals 15.2 over 2.5, which again gives me my answer of 6.08. Question 12b then says, on the grid, draw a sketch to show the relationship between y and x. Now, as it's a reciprocal graph and it's only worth 1 mark, you just want to make sure that your curve looks something like that. I would strongly recommend you don't label any of the numbers or the scales or anything like that. They're just looking for a general shape. So something along the lines that's asymptotic to the curve, to the axes, that looks generally a curve like so, should be absolutely fine to get the 1 mark. Then moving on to question 13, it says that a whole number from 1 to 16 inclusive, which means we're including those 1 and 16, is picked at random. And it says, using the Venn diagram, work out the probabilities, which of these probabilities is greater. So the first one is, well, let's start by filling these Venn diagram in before we start reading. So looking at this, we're using numbers from 1 to 16. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Now, from this, we want to work out m is the multiples of 4. So if I just colour code these, so multiples of 4 is going to be 4, 8, 12, and 16. So they're all the numbers that need to be inside this pink circle. Then if I use green for the factors of 12, so the factors of 12 are 1, 2, 3, 4, 6, and 12. So from this, I could then start filling numbers. So the numbers that are green, or green only, are 1, 2, 3, and 6. The numbers that are pink only are 8 and 16. The numbers that are both are 4 and 12. And the numbers that are not circled are 5, 7, 9, 10, 11, 13, 14, and 15. Now, from this, it then says, work out the probability of that number is a multiple of 4, given that it's a factor of 12. So basically, what this is looking at is we're only looking at the factors over the green circle. So we're going to be over 12, and how many, over, not 12 because that's the factor. So how many numbers are there in the green circle? Well, there are 6 numbers altogether, and how many of them are multiples of 4, which is 2, so it's going to be a third. Then if I look at this next one, so here I'm only looking at the pink, and again this will be very confusing because I'm writing in green. So you're only looking at the pink circle, and how many of those pink numbers, or how many numbers have we got in the pink circle? That's 4. How many of them are factors of 12? So that's 2, so that's a half. So the 2 probabilities I want to say, well, it's asking me is which of these 2 probabilities is greater. Well, from this we can then say that the probability that the number is a factor of 12 given it's a multiple of 4 is greater than the probability that the number is a multiple of 4 given it's a factor of 12. And again, that's it because a half is greater than a third. So that is what I would write as my final answer, which is a bit of a waffle, but it is important that you do write because it has asked you work out which of these probabilities is greater. So then moving on to question 14a, it says that the product of a times 10 to the power of b and 8.2 times 10 to the power of 7 is 2.952 times 10 to the power of 4, where a is greater than 1 and b is an integer. Work out the values of a and b. Well, product means multiply. So what we're going to do here is we're going to multiply these numbers. So I've got a times 10 to the power of b multiplied by 8.2 times 10 to the power of 7 equals 2.952.10 times 10 to the power of 4. Now comparing the coefficients, what I know is a times 8.2 equals 2.96. 2.952. So then a equals 2.952 rather, divided by 8.2, so a equals 0.36. Then moving on to b, well, I've got 10 to the power of b times 10 to the power of 7 equals 10 to the power of 4. So b plus 7, because we add the powers, equals 4, so b equals minus 3. Then if I put that in standard form, or copying in terms of substituting it back into this, so a times 10 to the power of b, well, I then get 0.36 times 10 to the power of minus 3. Now this is not in standard form because this number needs to be between 1 and 10. So if I make this number bigger, it means that I've got to make the power smaller. So then the correct answer is a equals 3.6 and b equals minus 4. Then moving on to question 14b, it says write down a number in standard form that is more than 35 million and less than 40 million. Now for this, what you want is a times 10 to the power of 7. Now a needs to be between 35 and 40. So, sorry, 3.5 and 4. So this can be any number. Let me just write that again. So a can equal 3.5 to a number to 4. So as long as you pick any number between 3.5 and 4, so let's go for 3.65 times 10 to the power of 7, then that will be good enough for you to get your marks. Then moving on to question 15, it says m equals xy minus 4x minus 6, where m is 15, x equals y. Work out the value of x. Well, if m equals 15, I can substitute that in. Then if I sub y equals x, then what I get is xx, which is x squared, minus 4x minus 6. Now this slowly looks like a quadratic, so I need to make it equal to 0. So I've got x squared minus 4x, take the 15 over, which then becomes minus 21. I can then factorise this because it does factorise, in which my two numbers are 7 and 3, and it's minus 7 plus 3. And you can have those brackets in any order, and it basically gives me my solutions of x equals minus 3 or 7. Now alternatively, you could have used quadratic formula, but I think factorising would have been a whole lot easier. Then moving on to question 16, it says Paul is competing in a pole vault competition. His first vault was 4.5 meters and his best vault was 12% higher than this. However, his best vault is 10% lower than the winning vault. And the question is asking us to work out the height of the winning vault. So first things first, so we can work out what Paul's best is by doing 4.5 multiplied by 12% increase, so it's going to be 1.12, and that comes up to an answer of 5.04 meters. Now this 5.04 is 90% of the winning vault, so this equals 90% of the winning vault. So then to work out 100% of the winning vault, all I need to do is do 5.04, divide that by 90 so it tells me what 1% is, and then multiply that by 100 so I can work out what 100% is, and I get a final answer of 5.6 meters. Alternately, you could have just done 5.04 divided by 0.9 if you're familiar with reverse percentages, in which you'll still get the same answer. Moving on to question 17, it says here are two similar solids, and we've got A and B. Solid A is 8 centimeters tall and B is 15 centimeters tall. The volume of A is 250 cubic centimeters. Is the volume of A approximately 4 times the volume of B? So let's have a look. So the first thing we can work out is we need to work out the length scale factor. Now the length scale factor is going to be 15 over 8. I don't know why I've written 9, so let me just correct that. So it's going to be 15 over 8. So that means then that the volume scale factor is going to be the length scale factor cubed. So then to work out the volume of B, well, that's going to be the volume of A, which is 250, and we multiply that by 15 over 8 cubed. Now if I type that all into my calculator, I get an answer of 1647.949. Now to then work out how many times bigger it is, well, if I do the volume of B divided by the volume of A, so that's going to be 1647.949 over 250, I get an answer of 6.599. So that means that the volume of B is 6.59 times bigger than the volume of A. So the box I need to tick is no. Then moving on to question 18, it says the diagram shows a hollow cylinder made from thick glass. The radius of the outer cylinder is 10 centimeters, the height of the cylinder is 25 centimeters, and the radius of the inner cylinder is 4 centimeters. And the question is asking us to work out the total surface area of the glass. Now the total surface area is the total wrapping of this particular hollow cylinder. Now for this, what you need to do is count how many parts we've got. Now actually there are going to be 4 parts that we need to be working out. Now the first part is this top bit here. Now, if you imagine it's a toilet roll, so this is the top of the toilet roll, and we've also got the base of the toilet roll. So in terms of the 2 little circles that we've got here, now we can do this by working out the area of the big circle minus the area of the small circle. And so here we've got area of a circle is pi r squared, so it's going to be pi times, and it's going to be 10 squared, so that's going to be 10 squared minus pi times 4 squared. So that becomes 100 pi minus 16 pi, which is 84 pi in total. Now we've got 2 of these, so then it's going to be 84 pi times 2, which is going to be 168 pi. And I'm just going to put that as highlight that. The next thing for me to then work out is to work out the inner tube. So let me not colour it in, so let me just get rid of that. And just get rid of all of that to begin with. So what I need to do is I need to work out what this inside of this is going to be. Now that's going to be a cylinder, when you break it down, is a rectangle. And let's do this in yellow. And the height of that tube is going to be 25, and the length of that is going to be the circumference of the smaller circle. So then this small bit here is going to be, or the circumference is pi times the diameter, so it's going to be pi times, and then if the radius is 4, the diameter is going to be 8, and I times that by 25, so that then becomes 200 pi. And there we go, so that's that one. Now the next thing for me then to work out is what this external rectangle is going to be, the outer rim. So that one is again going to be 25, but this time the length is going to be the circumference of the big circle. So for this, again, pi times d, the diameter of that big circle is going to be 20. So it's going to be pi times 20 times 25. And if I type that all into my calculator, I get 500 pi. So to work out the total surface area, I need to add up those three amounts. So the total surface area is going to be 168 pi plus 500 pi plus 200 pi, which comes up to a total of 868 pi, and that's going to be in centimetres square. Or if you want to write it as a decimal, just got to type that into our calculator, and we get an answer of 2726.9 centimetres square, and that's been rounded to one decimal place. So then moving on to question 19, it says prove, and then we've got 3x plus 1, x plus 7 minus 2x plus 5 squared is never positive. So we've got an algebraic proof question. So for this, what we need to do is do a bit of simplifying. So we expand the brackets. So if I expand these two brackets, I get x squared plus 8x plus 7, and that's minus, and then if I just put this in double brackets, I get 2x plus 5. So then simplifying this bit here, I get 3x squared plus 24x plus 21 minus, and it's going to be 4x squared plus 20x plus 25. Then remembering I've got a minus outside that bracket, I get 3x squared plus 24 plus 21, I've got the x, minus 4x squared minus 20x minus 25, because again that minus just changes the sign of everything underneath. Then if I simplify the whole expression, I get minus x squared plus 4x minus 4, and then from this I could do a bit of factorising, in which I end up with minus x minus 2 squared. I don't want to put a bracket there. So as you can see here, as minus 1 is a factor, so as minus 1 is a multiple rather, the answer will always be negative. And again, if you're not sure about how I've got from there to there, well, if I take a minus out, so I end up with x squared minus 4x plus 4, then I can factorise this, because I've got two numbers that multiply together equal 4, added together give me minus 4, so that's going to be x minus 2, x minus 2, which ultimately will lead me to that. Moving on to question 20, it says Sophia makes 5-digit numbers using all of these cards. How many different even numbers can she make? Well, in order for it to be an even number, then it needs to end in a 4 or a 6. Now, to end in a 4, then what we need to do is, well, if I take 4 out, well, then the options of the first number, well, there's 4 numbers to pick from. Then there's going to be 3 numbers to pick from. Then there's going to be 2 numbers to pick from. And then there's going to be 1 number to pick from. And then I've got another 1, and this represents the 4. So if I multiply those numbers up, the combinations, I get 24 combinations. So then if I then look for ends in a 6, then again, if I just get rid of that x, and this time put an x on the 6, then how many numbers have I got to choose for my first digit? Well, I've got 4 numbers. Then I'm going to end up with 3 digits. Then I'm going to end up with 2 digits. Then I'm going to end up with 1. And then I've still got my 6. And again, that is going to be 24 as well. So then looking at the total combinations, because obviously it could end in a 4 or a 6, it's going to be 24 plus 24, which is 48. So there are 48 different combinations. So now moving on to our last question, it says that a cylinder has a radius of x and a height of h. A hemisphere has a radius of 3x over 2. and the ratio of x to h is equal to 4 to 9. And the question is asking us to prove that the cylinder and the hemisphere have the same volume. So first of all, let's work out the volume of the hemisphere. So the volume of the hemisphere. Now to do this, what we need to do is we need to use this volume here, but divide it by 2. So the volume of the hemisphere is going to be 4/3 times pi times the radius cubed, all divided by 2. So then substitute the numbers in. Well, we know that the radius is 3x over 2, so it's going to be 4 over 3 times pi times 3x over 2, and that's going to be cubed, all divided by 2. So then simplifying this, we get 4 over 3 times pi, and then 3x cubed is going to give me 27x cubed, and 2 cubed is 8, and we're going to divide that all by 2. Now from this, what we can do is we can write it as a single fraction, so that then becomes 27 times 4, which is 108. So I've got 108, and then it's going to be pi x cubed, all divided by 24 divided by 2. Now I can move that 24 over, so it becomes 108 pi x cubed over 48, and then I can simplify the numbers, so then it becomes 9 pi x over 4. So that there is the volume of the hemisphere. So we just put a little bubble around that. So then moving on to the area of the cylinder. Now to work out the volume of a cylinder, that the formula is pi r squared times h. Now for this, I know that r equals x because it tells me so, but the next thing I need to do is work out what h is. So here, using this, I get x over h. If I write it as an equation, so x over h equals 4 over 9. Then do a bit of cross multiplying, so I get 9x equals 4h. So h equals 9x over 4. So then if I substitute that into the formula for a cylinder, then what I get is I get pi times the radius, which is x squared, multiplied by h, which is 9x over 4. And if I simplify all of this by writing it as a fraction, so I get 9x squared, or now I should put 9 pi, although it all doesn't really matter. But here I get 9 pi x cubed over 1 times 1 times 4 is 4. And as you can see, that these two formulas or expressions for the volume are the same. So what I can then write is that as these two things here are the same, so therefore both shapes have the same volume. And there we go.